In this video I'm going to explain thermodynamics, chapter 2, lecture number 1. I will take the first law of thermodynamics and conservation of energy. In this video I will give a simple introduction to thermodynamics and some basic concepts. I will not cover the non-flow equation and the flow energy equation because the video will be too long. Introduction. To understand and perform any sort of thermodynamic calculation, we must first understand the fundamental laws and concepts of thermodynamics. For example, work and heat are interrelated concepts. Heat is the transfer of thermal energy between two bodies that are in different temperatures and is not equal to thermal energy. Work is the force used to transfer energy between a system and its surroundings. Both work and heat together allow systems to exchange energy. The relationship between the two concepts can be analyzed through the topic of thermodynamics, which is the scientific study of the interactions of heat and other types of energy. To understand the relationship between work and heat, we need to understand a third linking vector, the change in internal energy. The principle of conservation of energy states that energy cannot be created nor destroyed, but it can be converted or transferred. With the interactions of heat, work and internal energy, there are energy transfers and conservation every time a change is made upon a system. However, no net energy is created or lost during these transfers. The relation began given by the famous equation: energy equal mass cross velocity of light square, where energy is a scalar quantity, not a vector quantity. M mass, C velocity. Types of energy. Now that the conservation of energy has been defined, one can now study the different energies of a system within a system. There are three main types of energy. These three types are kinetic energy and potential energy and internal energy. The kinetic energy is the energy of motion. Potential energy is the energy stored within a system as a result of placement or configuration. And internal energy is the energy associated with electronic and intermolecular forces. Thus, the following equation can be given: E total equal K plus P plus U, where K is the kinetic energy, P is the potential energy, U is the internal energy, and E total is the total energy in the system. While all forms of energy are very important, the internal energy U is what will receive the remainder of the focus. The law of conservation of energy reverses to an isolated system, in which there is no net change in internal energy, and where energy is neither created nor destroyed. Although there is no change in internal energy, energy can change forms. For example, from potential to kinetic energy. In other words, potential energy P and kinetic energy K sum to a constant total energy, E total, for a specific isolated system. E total equal K plus. The first law of thermodynamics. The first law of thermodynamics states that heat is a form of energy, and thermodynamic processes are therefore subject to the principle of conservation of energy. This means that heat energy cannot be created or destroyed. It can, however, be transferred from one location to another and converted to and from other forms of energy to obtain the general form of the first law of the thermodynamics. The following equation can be given. Delta U equal Q plus W. If the change of delta U is infinitesimal, then equation can be altered to du equal dq plus dw. Within the equation, it should be noted that u is the state function and therefore independent of pathways, while q and w are not.